So this lecture is on systems of nonlinear equations in two variables, and it is very similar to solving system of linear equations. We use substitution or the addition method. The process is pretty much the same. So here is the first example. Now I could do this by the substitution method, where the second equation, I could rewrite it as 4x equals y minus 1. But now the second equation tells me that y minus 1 is equal to 4x. So I'm going to take that information and plug it in the first equation, which should imply x squared is equal to 4x. So x squared minus 4x would equal to 0, which would mean x isn't common. So if I pull x out, I'll have x times x minus 4 equals 0, which would imply x is equal to 0 is one solution, and x minus 4 equals 0. That would be the second solution, so x would equal to 4. So we have two solutions for x, therefore we are going to have two solutions for y. So it doesn't matter which equation you use to plug it back in, the answer would be the same. So I'm going to plug in 4x is equal to y minus 1, so 4 times 0 would equal y minus 1, which would imply 0 is equal to y minus 1, therefore y is 1. Likewise, if I plug in x is equal to 4 in 4x equals y minus 1, 4 times 4 would equal y minus 1, which would imply 16 is equal to y minus 1, therefore y is equal to 17. Here we have a slightly more complicated example. Now, substitution has to be done carefully. If you pick the wrong one to substitute, you would have a challenging time in solving the system. So the easiest approach here would be to take that equation and rewrite it as x is equal to minus 2y. So I can take x is equal to minus 2y and plug it in the second equation. So minus 2y minus 1 squared plus y minus 1 squared would equal 5. So I could simply FOIL it, but before I FOIL, I'm going to look at minus 2y minus 1. It has a minus 1 in common. So if I pull that out, I have minus 1 times 2y plus 1 squared. Y minus 1 squared equals 5. The negative 1 when I square, it's going to become positive 1. So 2y plus 1 squared plus y minus 1 squared equals 5. Now I have to FOIL and simplify. So 4y squared plus 4y plus 1 plus y squared minus 2y plus 1 equals 5. 4y squared plus y squared would give me 5y squared. 4y minus 2y is 2y. 1 plus 1 is 2 equals 5. So 5y squared plus 2y plus 2 minus 5 would equal 0. 5y squared plus 2y minus 3 would equal 0. That is a quadratic equation, so we could either use the quadratic formula or ask the question, well, could we factor it? Looks like that can be factored. I could write it as 5y squared plus 5y minus 3y minus 3 equals 0. There is a 5y in common in the first two terms, so if I pull that out, I would have y plus 1. I have a minus 3 in common in the last two terms, so if I pull that out, I would have y plus 1 equals 0. And now I have y plus 1 in common, so if I pull that out, I have y plus 1 times 5 minus 3 equals 0, which would imply that there are two solutions, y plus 1 equals 0 and 5y minus 3 equals 0, which would mean y equals minus 1 is a solution, 5y would equal to 3, therefore y equals 3 over 5 is the second solution. Now that we have two solutions, we take the solutions for y and plug it in the original substitution that we used. So when I plug in y equals negative 1, that would imply x is equal to negative 2 times negative 1. Therefore, x is equal to 2 is a solution. And the next one would be y equals 3 over 5. If I plug it in the equation, I have minus 2 times 3 over 5, which would mean x is equal to negative 6 over 5 is the second solution. Here is an example where we have to use the addition method, which implies that we have to eliminate and substitute. So I am going to eliminate, it doesn't matter in this case, it is going to be challenging either ways. So I'm going to get rid of y, so I'm going to multiply the first equation by 3 on both sides, so 9x squared plus 6y squared equals 105. I'm going to multiply the second equation by 2 on both sides, 8x squared plus 6y squared equals 96. Now, if I subtract those two would go away. 9x squared minus 8x squared would simply be x squared. 105 minus 96 is 9, which would imply x squared is positive 9. And if we take the square root on both sides, x would equal square root of 9. Therefore, the solutions are x is equal to plus or minus 3. So plug in positive 3 in one of the two equations. So 3 times 3 squared plus 2y squared equals 35. Which would mean 3 squared is 9, 9 times 3 is 27, plus 2y squared equals 35. 2y squared would equal 35 minus 27. 2y squared would equal 8, which would mean y squared equals 4. And y equals square root of 4, which would give us y equals plus or minus 2. The key thing to notice here is I don't have to plug in x is equal to -3 to find the next solution for y. The reason being, if I plug in -3 there, I would still get 9 times 3 over there, which is 27. The reason being, -3 squared is still +9. So in one step, we found both solutions. So the solutions are x equals -3, x equals +3, y equals -2, and y equals +2. So here we have another example that we have to solve using addition method. So I'm going to move all the variables to one side. So the first equation would become -x squared plus y equals 5. The second equation is x squared plus y squared equals 25. And if I simply added those two, the x squares would go away. And I'll have y plus y squared equals 30, which would imply y squared plus y minus 30 equals 0. That is a quadratic equation, and we can either solve it via factoring or using the quadratic formula. This system, or this equation, looks as though we could solve it via factoring. If you can factor something, just factor it. Don't use the quadratic formula. So I could rewrite this as y squared plus 6y minus y minus 30. Minus 5y minus 30 equals 0. I have a y in common in the first two terms. If I pull that out, I have y times y plus 6. I have a -5 in common in the last two terms. If I pull that out, I have y plus 6. Now I have y plus 6 in common. So if I pull that out, I'm left with y minus 5, which would mean y plus 6 is equal to 0 and y minus 5 is equal to 0. Therefore, the two solutions are y equals -6 and y equals +5. In this problem, though, we've got to plug in the individual values to get the solutions for x, as they are different values. In addition, squaring is not going to simply give the same answer when I plug it back in, unlike the previous one where I could plug in -3 in any of the two equations and still get the same answer. So when I plug in y equals 5 in x squared plus 5, I would end up getting 5 equals x squared plus 5, which would imply x squared is 0, therefore x is 0. And plug in y equals -6 in y equals x squared plus 5, which would imply -6 would equal x squared plus 5. X squared would equal -11, which would mean x is square root of -11, which would give us a complex number, so plus or minus I square root of 11. So the solutions are x is equal to 0, x is equal to plus or minus I square root of 11, y equals -6, and y equals 5. So here is another system. As I've mentioned multiple times, it comes down to picking the right method and the right variable to cancel. Now you may ask me, well, should I use substitution method or should we use addition method here? The easiest approach would be to go for substitution. The reason being, if you look at the first equation, I could easily write it as y equals 1 minus x. I can take that and plug it in the second equation. So I have x squared plus x times 1 minus x minus 1 minus x squared equals negative 5. X squared plus x minus x squared. I'm distributing the x in the second term minus, I'm going to FOIL the last expression, 1 plus x squared minus 2x equals negative 5. Those two would go away. I have x, distribute the negative in, minus 1 minus x squared plus 2x equals minus 5. So I have minus x squared plus 3x minus 1 plus 5 equals 0. So I would get minus x squared plus 3x plus 4 equals 0. Now, I don't like having negatives in the leading coefficient, so I'm going to multiply by negative 1 on both sides. So I would end up getting x squared minus 3x minus 4 equals 0. Now that is a quadratic equation, and you've got to ask the question, should we use factoring or the quadratic formula? If factoring is going to work, let's just go with factoring. The equation looks as though we could use factoring. So x squared minus 4x plus x minus 4 equals 0. I have an x in common in the first two terms, and I have a 1 in common in the last two terms. And I have x minus 4 in common. So if I pull that out, I have x minus 4 times x plus 1 equals 0. Could set the first term equal to 0 and the second term or factor equal to 0. And I would, excuse me, end up getting the solutions as x equals negative 1 and x is equal to 4. I'm going to take those two solutions and plug it in the first equation that I had. So when x is negative 1, y would equal 1 minus 1, and 1 plus 1 is 2. When x is equal to positive 4, y would equal 1 minus 4. 1 minus 4 is negative 3. Therefore, the solutions are y equals negative 3, y equals 2, x is equal to 4, and x is equal to negative 1.